Now it's time to apply the cleaning and tokenization to all the 5,800 messages. But before we jump right into that, we have to review and practice a few key skills, and that involves slicing data frames and creating subsets. But not only that, we have to find a way to call our clean messages function on all the email bodies stored in our data frame. I'm going to change the cell to Markdown and quickly commemorate what we're doing. We're going to apply cleaning and tokenization to all messages. But before we dive into cleaning 5,800 email bodies, it'll be handy to review these techniques for slicing pandas data frames in series. So I'm going to add a little subheading here that reads slicing data frames and series and creating subsets. Okay, so recently we've used the @ attribute to select a particular cell or a scalar from our data frame. This was a very efficient way of accessing a particular entry in the data frame. And the way this @ attribute worked was that we had to specify both an index name and a column name. Now I realize the column name here is a string and the index name here is a number, but that's because we've given our index a numerical value here. The important thing to remember is that the @ attribute works off names. If you'd like to work off a position, say at position 1, position 2, position 3, then there is an alternative attribute that you can use instead. Let me show you what I mean. If we say data.iat square brackets and then 2 and then 1, we get the entry at position number 2 and column number 1. Column number 1 in this case is our messages column. Column number 0 was our category column. Column number 2 is our file name column. So with @ you're working off a name to get a particular entry, and with iat you're working off a location or a position. This is very, very useful for selecting a single message or a single entry in the data frame, especially if you're working in a loop or your code is iterating over a certain part of your data frame with a numerical value. This iat attribute will make your life a lot easier than the @ attribute, which works off the names. Now, what if you wanted to select a subset of the data frame instead? What if you wanted to select more than one value, more than one row, for example? In this case, you can use the iloc attribute. So this is data.iloc square brackets 0 and then a colon and then 2. This code here will select the first 2 entries in our data frame, the first 2 rows, if you will. If I hit Shift Enter, we can see what they are. If we wanted to select the first 5 rows, then we would simply substitute the 5 for a 2. And here's the challenge. What would you put in between the square brackets if you wanted to select the entries with doc ID 5, 6, 7, 8, 9, and 10? What would you supply here? In that case, you would go for 5:11. And that's because the first entry is at index 0. Now, the nice thing about this iloc attribute is it works both on data frames as well as series. So if I had only a single column selected, say data.message, I could still use this attribute, iloc, square brackets, and select only the first 3 entries in this series. This is very, very handy for creating or selecting a subset. So now that we've covered this, let's move on to the next question. Say we want to try out our clean message function on the first 3 emails out of the 5,800 odd emails. How would we do it? Well, step 1 is selecting these email bodies, of course, and we've done that right here. Step 2 is using the pandas apply function. Now I absolutely love this function. This is genius. Say we store these 3 entries in a series, call it first emails. Set that equal to data.message.ilog 0 to 3. And then we can take this series, put a dot after it, use apply, parentheses, and then supply the name of our function, which was clean_message. Note, there's no parentheses after clean_message. We're supplying just the name of our function to the apply method, which we're calling on our series object here. Let's see what happens. What we get back is kind of a list of lists. We've got all our words in a list split out for our first email. Same thing with our second email. And again, we've got all the words split out for our third email as well. If you're curious what kind of type of object we're dealing with here, you can take a look by just wrapping this in the type function, and you see that you still are working with a series. So that's good. That's really, really interesting. Now, I'm going to give this thing a name. I'm going to call it nested_list. And I'm going to set it equal to the output from this apply function. I'm calling it a nested list because effectively I've almost got like a list of lists, right? Each individual entry in my pandas series here is a list. But here's a question. What if I wanted just one list of words? What if I didn't want a list of lists? Let me hit Shift Enter on this. I can create an empty list here and then just write a for loop, right? A nested one probably. I have to go over all the items in the list first. So I'll say sublist in nested list. That's my first part of my loop. And then my second part of my loop, the inner loop, I'll say for item in sublist. The outer loop goes over all the lists, and the inner loop goes over all the individual words in each sublist. I'll put a colon there, and then say flatlist dot append parentheses item. That will pretty much do the job. So if I wanted to check what the length of this flat list is, then I can use len parentheses flat list. Let's see what we get. 390, right? So that's 390 words now in a single list. If we wanted to take a peek what it looks like, then it looks like this. It's just all the email words in one big list. And, you know, this is certainly one way of doing it. But let me show you an alternative. Let me show you how this would look like with something called Python list comprehension. So I'm going to comment all of this out. If you select the text like me and then press Control/, this is the shortcut for commenting out an entire block of code. If you're on a Mac, of course it'll be Command/, but for everybody else, Control/. The Python list comprehension syntax for accomplishing exactly the same thing as with these two nested loops looks like this. So I'll still use flatlist as my variable, and I'll have square brackets, and then I'm basically going to move my loop inside these two square brackets. I'll say item for sublist in nested list for item in sublist. This here you'll recognize as the outer loop for sublist in nested list, and this here you'll recognize as the inner loop for item in sublist. This first bit of code is what appends the item to the list. Let's see what happens when I run this again. I in fact get the exact same result. So now you've got another application of this Python list comprehension syntax. You can often use it instead of nesting these for loops. Now, you've probably put 2 and 2 together on how to call our clean messages function on all the 5,800 odd items. We're going to do something very, very similar to what we did a minute ago. We'll create a nested list and we'll set it equal to data.message.apply parentheses clean message no HTML. This here will use apply on all the messages in the data frame. Now before I hit Shift Enter and execute this code, I'll use a little bit of Jupyter magic. I'll put 2 % signs here and then use that keyword time. And what this will do is it'll spit out how long this computation will take. So this is kind of like a little bit of a benchmarking tool for looking at the performance of your Python code. And it'll also help you see just how long it takes for my code to execute on my computer, and you can compare this to your own. The first thing I'm seeing here is that our beautiful soup package seems to think that we're trying to open a website. Now this is definitely not the case, so this user warning is a little bit unnecessary. Our code's still working, nothing's breaking, but this is something that Beautiful Soup has included in their code as a suggestion for people who are looking to open websites. The other thing that you can see is that in order to apply this function to all my 5,800 odd messages, is that my computer ran for like a good minute. It got there in the end, but it definitely did some work. So let's check out the head of our nested list. Let's look at the first few lines. Looks good. What about the tail? The last few lines. Brilliant. That also looks good. Nothing unexpected.